Okay, so this video is going to serve as our day three unit three, day three of geometry. In it, we're going to briefly talk about how to solve trig equations um, that are beyond quadrant one, right? So angles larger than 90 degrees or pi over 2 radians, which basically means we're going to have multiple solutions now, just because of the nature of this, the unit circle, right? So because of the nature of this, that means trig equations can have multiple solutions. Okay, and that goes back to reference angles, which I will mention uh, throughout this video and obviously throughout the lesson in actual class. So this first example, we have sine theta equals 1/2. Well, real simple. We're just going to do arc sine. And the arc sine of 1/2, of course, tells us that theta is going to be equal to 30 degrees. Okay, now that is not the only answer, right? So we see here sine at theta equals 30 degrees is 1/2, right? But where else do we have this same reference angle of 30 degrees coming up, right? Because sine is analogous to y, so we know we're positive in quadrant one and also in quadrant two with sine because that's where y is positive, right? And here we see another sine value of 1/2, which means our other solution, which is obvious given the fact that the reference angle of it is also 30 degrees, our other solution is 150 degrees. Okay, so that would be my second solution, right? Because we're being told we're going all the way around the unit circle, one revolution from 0 to 360 degrees. Okay, so that's an important distinction rather to make. Okay, so here we have another. Okay, so we're just going to do this one simple. We just do arc cosine on both sides real quick. So arc cosine of 1, right? Which means theta must be equal to 0 degrees. Now, is that the only solution? Well, no, it's not. We see it happens at 0 degrees, but it also happens at 360 degrees. Okay, so we see we have two solutions there also. Here's another one. Right here, we see we can make use of the tangent rational identity, right? So the tangent rational identity simply says that tangent theta is equal to sine theta over cosine theta. So basically, if you have the sine of an angle divided by the cosine of the same angle, it's the same thing as just taking the tangent of that angle, right? So I can rewrite that to just say negative tangent theta, and it already looks much simpler than it did. Then I multiply both sides by -1. And we simply have theta equals the arctangent of negative square root of 3, right? And we know our solution there, one of them at least, is going to be 60 degrees in quadrant 1. But this is kind of tricky, right? So remember, tangent is analogous to slope. Okay, so let me delete some of these here, give myself some room. So if tangent is analogous to slope, and we're looking for a negative tangent, well, that means, first of all, I just made a mistake. It is not going to be 60 degrees. But let's look at our unit circle here and see what it is in fact going to be. So tangent, arctangent of negative square root of 3. So normally square root of 3 for tangent is going to be 60 degrees, right? Okay, so tangent is analogous to slope, okay? Except in this case, we're talking about negative square root of 3, right? So if we're talking about negative, we're talking about a negative slope. Okay, so our reference angle, obviously, yes, it's 60 degrees, right? But we're not going to be in quadrant 1 and 2. We're going to be in quadrant uh, 2 and 4. Okay, and let's talk about why that is. Well, here and here, so I have a reference angle of 60 degrees, right? Here, I have that same reference angle that I need of 60 degrees. And let's talk about what I mean by slope. Well, if we follow this line here, we see that we have a negative slope. Okay? So that undoubtedly means our two solutions are 120 degrees and 300 degrees. Okay, moving on to our next example. Okay, so here we see another one of our trig identities, namely the Pythagorean identity. The Pythagorean identity says that the sine of an angle squared plus the cosine of the same angle squared is going to always be equal to 1. Okay, so that means we basically just have 1 over 2, because this is equal to 1, is equal to cosine theta. Take the arc cosine of both sides. Okay, and we see that our angle is equal to the arc cosine of 1/2. So that means we are at 60 degrees in quadrant 1, because this is a positive 1/2, right? Where else are we looking for our cosine? So where else is x or cosine positive? Well, quadrant 1, yes, and also in quadrant 4. Okay, so we're looking at a reference angle of 60 degrees. So we're going to come down. So we see one of our solutions, obviously, is 60 degrees, but we're going to come down 60 degrees into quadrant 4 for our other solution of 300 degrees. Okay, so 60 and 300. So that's in quadrant 1 and in quadrant 4. So every time you're solving these, you have to ask yourself, where is sine or cosine or tangent positive or negative in what quadrants? Okay. And last example, so we have to be careful with this one. So sine squared theta equals 3 over 4. Well, we don't want to know sine squared theta. We just want to know sine theta. So we're going to take the square roots of both sides. Now, this is where we have to be careful. Anytime we take a square root, we have to say plus or minus. Okay, so it's plus or minus the square root of 3 over 4, right? And we're going to simplify this further to say plus or minus the square root of 3 over 2. Okay, we can do that because of the quotient law of radicals. Okay, so square root of 3, can't simplify that. With square root of 4, we can say that that's 2. Okay, and that's exactly what I did over here. Okay, so now I know theta is equal to, I had a brain fart, it shouldn't be theta, it's sine theta. Okay, so now we take the arc sine, and we can say that theta is equal to the arc sine of plus or minus the square root of 3 over 2. Okay, so that means we have our two solutions for the positive square root of 3 over 2 and our two solutions for the negative square root of 3 over 2. So let's start with the positives. So we know that sine is positive in quadrants 1 and 2 because that's where y is positive, right? So we're looking at positive square root of 3 over 2. Well, that tells us our two solutions are going to be 60 and 120. Those were for our positive square root of 3 over 2, right? Now, what about our negative square root of 3 over 2? Well, sine is negative in quadrants 3 and 4. Okay, so we're going to have to use a reference angle. So 60 degrees, 60 degrees, right? So that means we're going to come down 60 degrees. And that's going to put us here at 300 and here at 240. So the other two solutions are 240 and 300 degrees. Okay, so that does it for this video. Covered a whole bunch in it all at once. The main thing that I'm going to say in summary is when you're solving these, when you get to the end, right? So, for example, this guy right here, theta equals the arc cosine of positive 1, right? Ask yourself, where is cosine positive, right? Same thing over here. We had arc tangent of negative square root of 3. What quadrants did that have to be? Well, we knew it had to be quadrants 2 and 4 because that's where we have lines that have negative slope. They would pass through quadrants 2 and 4, right? Um, and just like how we did on the last one, anytime you take a square root in algebra, it's always positive or negative. Okay? If it's pure geometry, that's another story, but we're doing algebra here as well, so can't be so simple with it. Right? Like always, shoot me an email or come and find me. You know where to find me if you have any questions. Otherwise, goodbye.